What if we have an equation like this we want to solve for exponents, but the bases aren't the same? So we can't do that little trick in the last video. Well, what we could do is we could take logs of both sides and just do ln. You do something to one side, you have to do it to the other side, because then what this does is let me use that log property that I can now bring down the exponent, and I'm left with ln of 2. And I bring down this side, the exponent, and I'm left with ln of 7. And from here, I could distribute ln of 2 to 2x and to 3, and then ln of 7 to x, and ln of 7 to negative 2. So that becomes 2x ln of 2 plus 3 ln of 2 equals x ln of 7 minus 2 ln of 7. All right, I'd like to get the x's all on one side, so I'm going to subtract x ln of 7 on both sides. And then also at the same time, let's go ahead and move something that does not have an x to the other side. So 3 ln of 2. So of course, this cancels on this side, that cancels on that side. So let's just write this back out. 2x ln of 2 minus x ln of 7 equals minus 2 ln of 7 minus 3 ln of 2. So I just rewrote it. Well, on this side, I want to still isolate x, and it's in both of these, so I could simply factor it out front, and I get 2 ln of 2 minus ln of 7. And this is still this business over here, ln of 2. And then finally, to get x by itself, well, let's just divide this piece on both sides, and that'll cancel it. Well, dividing it on this side, oops, actually gives me my final answer in fractional form. 7. And then if you throw this in a calculator, you should get approximately 10.67. So that's the fractional answer, and then of course they'll ask you for the decimal answer.